Hello, my name is Joshua Mugabi. I welcome you to Thermodynamics. A well-stoppered thermos flask contains some ice cubes. This is an example of closed system. Open system. Isolated system. Non-thermodynamics system. The answer is isolated system. It is an isolated system. For the reaction, carbon, which is a solid, reacting with oxygen in gaseous state, it gives us carbon dioxide as a gas. Delta H is greater than delta U. Delta H is less than delta U. Delta H equals to delta U. None of these. And the answer is delta H equals to delta U. Here, delta Ng RT equals to 0 because reactants and products contain same number of gaseous molecules. So that delta H equals to delta U plus delta Ng RT, giving us delta H equals to delta U. For an ideal gas, Cv and Cp are related as Cv minus Cp equals R. Cv plus Cp equals R. Cp minus Cv equals RT. Cp minus Cv equals R. And the answer is Cp minus Cv equals R. For an ideal gas, Cv and Cp are related as Cp minus Cv equals R. The least random state of the water system is ice. Liquid water. Steam. Randomness is same. The answer is ice. The least random state of water system is ice. Considering entropy, thermodynamic parameters, the criteria for spontaneity of any process is change in entropy system plus change in entropy surroundings is greater than 0. Change in entropy system minus change in entropy surroundings is less than 0. Change in entropy system is greater than 0. Change in entropy surroundings is greater than 0. The answer is change in entropy system plus change in entropy surroundings is greater than 0. The criteria for spontaneity of any process is change in entropy system plus change in entropy surroundings is greater than 0. The enthalpy change in a reaction does not depend upon the state of reactions and products. The nature of reactants and products. Different intermediate steps in the reaction. Initial and final enthalpy of the reaction. The answer is different intermediate steps in the reaction. The enthalpy change is a state function, so it does not depend on the different intermediate steps in the reaction. The correct relationship between free energy change in a reaction and the corresponding equilibrium constant Kc is Negative free energy change is equal to RT ln Kc. Change in free energy equals to RT ln Kc. Negative change in free energy is equal to RT ln Kc. Change in energy is equal to RT ln Kc. The answer is negative free energy change is equal to RT ln Kc. The relationship between free energy change in a reaction and a corresponding equilibrium constant Kc is change in energy is equal to negative RT ln Kc, or negative change in energy is equal to RT ln Kc. What is the entropy change in joule per kilogram per mole when 1 mole of ice is converted into water at 0 degrees Celsius? The enthalpy change for the conversion of ice to liquid water is 6.0 kilojoules per mole at 0 degrees Celsius. (20.13), 2.013, 2.198, 221.98. The answer is 21.98. The entropy change ds is equal to d2 rev divided by T is equal to ds, equaling to 6,000 joules per mole divided by 273 Kelvin, giving us the ds giving us 21.978 kilojoules per mole. If liquids A and B form an ideal solution, the entropy of mixing is 0. The free energy of mixing is 0. The free energy as well as the entropy of mixing are 0. The enthalpy of mixing is 0. The answer is the enthalpy of mixing is 0. If liquid A and B form an ideal solution, the enthalpy of mixing is 0. When water is added to quicklime, the reaction is explosive, endothermic, exothermic. The answer is exothermic. When water is added to quicklime, the reaction is exothermic. Calcium oxide plus water, we get calcium hydroxide. Enthalpy change is exothermic. Hello, my friends. Thank you very much for participating in thermodynamics. Please do like, share, and subscribe.